So let's have a look at this question. So it says figure 7 shows a sketch of a curve with equation y is equal to 4x e to the minus 2x. So we can see the curve on the diagram where x is greater than 0 or equal to 0. Line L is normal to the curve at point 1 for e to the minus 2. You can see the line, you can see that intersection point. The finite region R, shown in figure 7, is bounded by the curve, the line, and the x-axis, and we want to find the exact area. So straight away, if I'm seeing exact area, I know I need to be working within exact values. So I shouldn't be rounding anything. There shouldn't be like decimals. It should all be, if it's e's, keep them as e's. Don't use decimals or anything in those places. So let's first of all, before we charge in, let's figure out what information do I need to solve this question. So exact area, so area under a curve, I should be thinking integration. So I know I need to integrate that curve to find the area of it. That was meant to be an integral sign. I just drew an F. So I need to integrate my curve f of x, and then I need the finite region, the limits. I know one limit is 0, and then I need the other x coordinate. Well, I know I need to go up to this point here. And I can see where that coordinate P is. I know that x coordinate there is 1. So I need to integrate that curve between 0 and 1. But I'm hoping when I've drawn that line, you can then see that's going to give me more than the area of R. It's going to give me this triangle here, which I don't want. So I'm going to have to basically remove the area of that triangle. So I need to basically find the area under that line L now. And hopefully you can see that it is a triangle. So, and it's a right angle triangle. So I can just basically use the areas half base times height. So I basically then need to take away the area of that triangle there. So I now need to know the base and height of that triangle using that line. Well, the height I can find out already because the height of that triangle is just going to be the y coordinate of P there, because I know y is 0 at the start, at the bottom of the triangle, and at the top the height is the y coordinate there. So the height is 4e to the minus 2. And then for the base, well, I know that x coordinate P is 1, but I need to know what this value is here, meaning I need to know what this coordinate is going to be on the line where y is 0. So I need to find that coordinate. How am I going to find that coordinate? Well, I need to know the equation of that line. How can I find the equation of that line? Well, I need to know a point on the line, which I do know, and I need to know the gradient. So can I work out the gradient? Well, I'm told that the line is normal to the curve at that particular point. So yes, I can, because I can find the gradient of the curve at that point and then find the negative reciprocal to get the normal. So all that is to say that my first step that I'm going to do is I want to find the equation of line L. To do that, I first of all need to find the gradient. So I know the point P is at 1 for e to the minus 2, but I need to know what M is. That's what I need to find the gradient. So let's start with our curve, because we're going to find the gradient of the curve at that point and then find the negative reciprocal. So the curve is 4x e to the minus 2x. So I need to use product rule because I've got two functions multiplied together there. So for product rule, I like to start just by writing out what u and v are and what the derivatives of those are. So, oh, my v is a bit weird, isn't it? So I just put the left one as v, so the left one is u, the right one is v. It doesn't, for product rule, it doesn't matter which one's which. For quotient, it does matter. Product, it doesn't. So differentiate 4x is 4. And then differentiate e to the minus 2x, that'll be minus 2e to the minus 2x. And then for product rule, it's v u dash plus u v dash. So that's product rule. So let's just bung our u's and v's and all that into there. So it's going to be, I can see that's going to be 4 e to the minus 2x for vu dash, and then uv dash is going to be minus 2e to the 2x times by minus 4x. So that, is equal to 4x. My equals sign is playing up on me there. That is a minus, that's an equal sign. So it's going to be minus 8x e to the minus 2x when I multiply all that out. So that's dy by dx. So I'm trying to find the gradient at that coordinate there. So now I'm going to substitute in x is 1 to find out what the gradient is going to be. So dy by dx now is going to be, well, it'll be 4e to the minus 2. And then it'll be, that plus minus is just a minus. So it'll be minus 8e to the minus 2. And then we can simplify that, and that will give us minus 4e to the minus 2. So that's our gradient. So now I want the gradient of line L, which I know is the negative reciprocal because I know it's normal to the curve at that point, meaning they're perpendicular. So I'm just going to rewrite that as a fraction. So that would be minus 4 over e squared. So then if it's negative, make it positive and then flip it. So that would be e squared over 4. That's the gradient of L. So, or I could write that as a quarter e squared. It doesn't really matter. And then we know a point on the line, we know the gradient, we can put it into the equation of a straight line now. So we'll do y minus y1, and I've forgotten what the coordinate of y is, so it's 4e to the minus 2. So it's y minus 4e to the minus 2 is equal to m, which is our gradient, e squared over 4, and then x minus x1, and the coordinate at that point is just 1. So we end up with this, and then I now want to find that, I want to find the intersection with the x-axis. So now I need to sub in y as 0. So now I'm finding coord when y is equal to 0. So I can get the base of my triangle. So I'm just going to set y to 0 there. So it'll be 0 minus 4e to the minus 2 is equal to e squared over 4x. I'll just expand this out. Minus e squared over 4. And then I need to rearrange that and make x the subject of that equation. So let's just move the x's all across. So, sorry, move everything else across. So it'd be e squared over 4. And I'm going to write that as 4 over e squared here is equal to e squared over 4 x. So I've got that. And then I need to multiply everything now by 4 over e squared. So when I do that, e squared over 4 times by 4 over e squared, that's just going to get me 1. And then minus 4 times by 4 get me minus 16. And then e squared times by e squared is e to the 4. And then that will just become x. So now I know my x coordinate when y is 0 on that line. So just to be clear, that coordinate is now 1 minus 16 over e to the 4, 0. So now we need to find the area of that triangle, because remember we're doing all this just to find that x coordinate so we can then find the area of that triangle. So step 3 is the area of the triangle. So remember what our triangle looks like. So we had our point here was at, and I've already forgotten what it is, 1, 4e to the minus 2. It's this point, and then this, oh, I'm making it bigger. Don't know what I was doing there. And then I want this point, which I know what it was. It was at 1 minus 16 over e to the 4, 0. So now let's think about our base and height. So we know, we've already said that we know the height here is 4e to the minus 2. And then the base, it's going to be the difference in our x values, isn't it? So the difference in our x values, so it's going to be 1 minus, and then it will be this x coordinate we just worked out. So 1 minus 16e to the 4. Don't know why I put a line there. So when I do that, what is that going to get me? Well, the 1's are going to cancel out, 1 minus 1. And then we end up with a minus minus, so it just becomes 16, I'll call it e to the minus 4. So that is the base of my triangle, and I have the height of my triangle. So now we can do a half base times by height now. So the area is going to be, where's my pen gone? There we go. A half times by 4e to the minus 2 times by 16e to the minus 4. And then when I do that, the half times 4 is going to give me 2 times by 16, that's 32. And then e to the minus 2 times by e to the minus 4 gets me e to the minus 6. So the area of my triangle, after all of that, is this. And it's an exact value, which is what we wanted. So that's got me the area of the triangle. Now I'm on, what step was that? That was step 3. So now let's go on to step number 4. And step number 4 is now the area under the curve. Under the curve. So the curve, if we remember, if we go back to here, there's our curve. If you remember, the equation of that was 4x e to the minus 2x. So to find the area, we need to integrate that. And then because we've got two functions multiplied together, we're going to have to use integration by parts. And the formula for integration by parts is as follows. So it's u, first derivative of v is equal to uv minus the integral of v, first derivative of u. So remember that u and v dash are what we start with. So we need to select which one's going to be which. Now, if you have an e term, that tends to be your v dash. But to be honest, if you're unsure, play around with it. If it doesn't work, try it the other way around. Worst case scenario. So I'm going to, so again, I like to list them out so I don't get confused. So u is 4x, and then I might as well find u dash while I'm here. That's 4. And then don't get confused because I know we did stuff with u's and v's before. These are different u's and v's now for the integration and differentiation. Don't get them confused because now v dash, if we can see here, v dash, and that's our v dash there. So that's e to the, is it minus 2x? So I missed an x off there. Yes, I have. It should be a 2x. I thought it should be. So e to the minus 2x is our v dash. So then we need to integrate that and find what v is. And if you're integrating, you basically divide by the constant term on x. So that would be minus e to the minus 2x over 2. So there are u's and v's. So they are different to the ones we used when we differentiated it. So we probably should call them something different, but we don't. I don't know why we don't. But anyway, that's what we do. So then let's just put that into our integration by parts formula. So now putting that into the right-hand side. We basically define what u and v are based on the left-hand side. We are now putting it into the right-hand side. So uv will be minus 2, because I'm going to do the 4 times by half would be minus 2. And that'd be minus 2x e to the minus 2x. And then that'll be minus the integral, and we'll deal with the limits later. We'll just integrate it for now. And then v is e to the minus 2x over 2, and u dash is 4. So that'll be minus 2, and that'll be e to the minus 2x there, won't it? Dx there. So we end up with that. So now let's just evaluate that integral now. So obviously this bit stays the same. And I'm going to just put my brackets in because I know I need to put some limits in a bit. And then when I integrate this thing here, that is going to become, I might just do it on the side here just so it doesn't interfere with the rest of our working out. So again, we divide by the coefficient of x. So minus 2 divided by minus 2 would just give us 1, wouldn't it? So it'd just be e to the minus 2x there. That's what that would come out to. So that gets us e to the minus 2x. And just be careful, because when I've been marking this, a lot of people have gone wrong here with the signs. So when we integrate that, it becomes positive e to the minus 2x, and then you're taking that away. So it overall becomes e to the minus 2x. So be careful. Like, you want to write an extra stage of work in there to get there. But this thing becomes the minus 2 e to the minus 2x becomes e to the minus 2x, and then you take all that away. So that's what that becomes. And then we need to put our limits in. And our limits, if we go back up to the top, because I've forgotten what they are now. Our limits were 0 and 1, as you can see there. Okay, we're getting there. We're getting there. So now let's put our limits in. So that would get us minus 2 e. It would just be e to the minus 2. And then that would be minus e to the minus 2. And then we take away that first term because our limit is 0, would just be 0. So it'll be minus, and then it'll be just, it'll be e to the 0, and it would be 1, so it'll just be a minus 1 there, like so. So then let's just evaluate what that is going to be. So this first bracket will become minus 3e to the minus 2, and then we've got a minus 1, which would get us a plus 1. So that is the area under the curve. So the final step is to find the area of R. So I think, is this step 5 now? I'm going to call it step 5. It might be step 4. I can't remember. So 5 is now, we want to find the area of R. And if we remember, we basically said that was the area under the curve minus the area of our triangle. So the area under the curve we just worked out. You can see that there. I'm just going to write it this way around. So it's 1 minus 3e to the minus 2. And then if we go back and find what the area of the triangle was, because I've forgotten myself, the area of my triangle is 32e to the minus 6. So all that minus that 32e to the minus 6. I'm just putting that in blue so you know where that's come from. That's that bit. And, oh, it's minus 6, not minus 2. And that's your answer. That's the final answer. So if you want, I'll write it a bit closer together. But yeah, that's it. And I guess you could do some factorising with the e's if you really wanted to. But it doesn't say to leave it in a specific format. It just says exact value. And that is the exact value.